Hello students, this is Ajit Pal Singh from Apollo Academy Sangrur. In the previous lectures, we have discussed about the single displacement reaction and various kinds of reaction. And today we are going to discuss about double displacement reaction. Yes, student. So, what are the properties of a double displacement reaction? So, students, in a double displacement reaction, first of all, we have two salts. We have two salts as reactants. So, let us suppose here is one salt known as cation 1, anion 1. This is a salt 1, plus it is in aqueous form. It will be in aqueous form. It will be dissolved in water. Plus cation 1, cation 2, anion 2. This is salt 2. So, when the reaction will proceed, the answer will become cation of first salt will move to anion of second salt, and anion of first salt will move cation of second salt. So, the answer will be anion 2 cation 1 plus anion 1 cation 2. This will be the answer. So, this is the fundament of double displacement reaction, and the product will be like as made by the valency or oxidation state of the reactants. So students, in this, these can be PPTs known as precipitates and which can settle down. ये settle down हो सकते हैं बेटा ये precipitates. This can be an aqueous solution. ये पानी दे विच घुलिया होया solution हो सकता. It means double displacement reaction can give PPTs, precipitates. ठीक है बेटा. Second thing, there is a color change has been observed in some reactions. So these are the two characteristics of double displacement reaction, and this is the mechanism how double displacement reaction occurs. So when we solve these reactions according to this phenomena, according to the phenomena of mechanism of double displacement reaction, we will come as, let's suppose this is aqueous, this is a salt dissolved in water, this is also a salt dissolved in water. This is colorless, it is also colorless. It is like a simple salt dissolved in water, it doesn't have any color. This is lead nitrate, this is potassium iodide. Now, lead nitrate when dissolved in water will split up in Pb2 positive, that is anionic part, and NO2 nitrate, NO3, and here is 2, NO3 1 negative. It will behave like this. and Ki will behave like K positive, I negative. Now, according to the phenomena, this lead will make a bond with iodine, and this potassium will make a bond with the nitrate, and the resultant will be PbI2 plus KNO3. These are yellow precipitates. Color change, colorless, and it give rise to a product which is yellow PPTs. It means it will not dissolve, it will settle down. This sign shows the settle down of the PPTs, and in this is aqueous solution. It means KNO3 will be in dissolved form. KNO3 will be in dissolved form. So students, if we take this reaction in two separate test tubes, let us suppose this is a solution of PbNO3 bracket 2, and this is the solution of Ki. So when we mix these, we will have this kind of stuff in our test tube. We will have yellow precipitates or yellow colored precipitates dissolved at the bottom or at the sides where the reaction occurs, and in between these we will have Ki, not Ki, KNO3, and this is your PbI2 yellow colored precipitates, or you can say little bit orange colored precipitates. So you have observed, what do you have observed? That there is the displacement of the anion of first salt to the cation of second salt, and vice versa. That's why it is called double displacement reaction. It is typically similar to single displacement reaction, but in those reactions only one atom get displaced. In this reaction, because we are taking both the salts, we are taking both as salts in aqueous solution, that's why both the salt, the anionic part and cationic part of both the salt get interchanged. So when they get interchanged, this kind of reaction is called double displacement reaction. Same phenomena will be happen over here. This is aqueous. This is barium chloride, and this is sodium sulfate. So barium chloride when reacts with sodium sulfate, let us suppose take the phenomena as barium chloride. Ba will behave like Ba2 positive, chlorine will behave like Cl1 negative. Now sodium will behave as Na1 positive, and SO4 will behave as 2 negative. This will go with this. This will go with this. And the product will be BaSO4 plus NaCl. These are precipitates. which will settle down and it will be in aqueous form. It will be dissolved in the solution after the reaction. So here precipitate formation occurs. Now the same phenomena will happen here, and we will have as expected products like AgCl plus NaNO3. In this will be the precipitate and NaNO3 will be the in aqueous form. So these are some kinds of reaction, but the most important reaction in double displacement reaction is the reaction between lead nitrate and potassium iodide, which is the reaction given in the exercise of your NCERT and also in the practicals of your 10th class. You have to remember that there is a color change from colorless to a colored compound, lead iodide, which is yellow in color, has been formed. So we have discussed, so far as we have discussed a number of double displacement reactions. Now we will move to some other double displacement reactions, and the balancing part is up to you. I will not balance the equation because you are very well known to the balancing part. So some more reactions in double displacement reaction are copper sulfate plus ammonium hydroxide. Both are in aqueous. Now the product will be like copper 2 positive, sulfate 2 negative, ammonium 1 positive, hydroxide 1 negative. Now this will move towards this and this will move towards this. Now the product will be copper hydroxide, which comes to be Cu bracket OH2. Why this? Because Cu2 OH1 and the product will be that. And NH4 1 positive, it means NH4 1, SO4 2, and the product will be NH4 bracket 2 SO4. Copper hydroxide and ammonium sulfate. Copper hydroxide and ammonium sulfate. This will be in aqueous form and it will form precipitates of blue color. Because copper has every salt of copper has a characteristic color of blue. So this will form a blue colored precipitate due to that double displacement reaction. I am hoping that you will be fairly known to the mechanism which is going around when the reactants react and how they form product. It is typically that firstly they will move to their ionic form and after that their ions will interact. After that their ions will interact and they will form a product. Next reaction is aluminium chloride. Aluminium chloride. This will be aluminium chloride because aluminium has a valency of 3 in aqueous form plus ammonium hydroxide. Ammonium hydroxide. Ammonium hydroxide. Now what will be the product? The product will be as by the same phenomena, that is aluminium 3 positive, chlorine, that is also aqueous, chlorine 1 negative, and it will behave like NH4 positive and OH negative. So an ion of first salt will make a bond with cation of second, and anion of second will make a bond with cation of first. So the product will be Al3OH1 and the product will be Al bracket OH3 plus ammonium chloride, that is NH4Cl. This is 1, this is also 1, so NH4Cl. These are the white PPTs. White PPTs. And they will settle down, it will be in aqueous form. Next reaction that we will move to is the reaction between sodium hydroxide and hydrochloric acid. Sodium hydroxide and hydrogen chloride, that is hydrochloric acid. Sodium hydroxide is in aqueous form and hydrochloric acid, obviously it is in aqueous form. So the product will be Na positive, OH negative, H positive and Cl negative. This will make a bond with this and these will make bond together. So this is become NaCl plus H positive and OH negative. This will interact and form H2O, water. This kind of reaction is an example of neutralization reaction as well. This kind of reaction is an example of neutralization reaction. Why this is called neutralization reaction? Because the hydroxide part, it is a base. It is a compound having basic properties. This is an acid. So, when base and acid reacts by the phenomena of double displacement reaction, by the phenomena of double displacement reaction, the product will be a salt, NaCl, this is salt, and water. We can have a plenty of reactions like this, in which a base, what do you mean by a base? So, in this whole chapter, we will only assume a base is a compound which have OH negative as cation. Which have OH negative as cation, that kind of compound is called a base, in which there is hydroxide ion is present, that is called a base. A base is a compound in which hydroxide ion is present, and for an instance we will have KOH is a base, NH4OH is a base, NaOH is a base. A lot of bases are there, but this is the strongest base. As for this, any compound which have OH is called a base, and any compound which have only hydrogen atom like HCl, H2SO4, HNO3, this is acid. We will discuss these bases and acids in next chapter, because our next chapter is acid, bases and salts. So we will discuss more about these bases and acids in next chapter. So for this chapter you have to only assume that any compound containing OH is a base and containing hydrogen as a positive part, or you can say as an anion, is a acid. So let us take another example of this kind of reaction known as neutralization reaction. these kind of reactions in which base and acid combine together, and by following the double displacement phenomena, they give a salt and water molecule, is called neutralization reaction. Neutralization reaction. So another examples of neutralization reactions are NaOH plus H2SO4. Same phenomena. Na, this is aqueous, and obviously this is aqueous, this is base, sodium hydroxide, and this is acid, sulfuric acid, hydrogen sulfate, sulfuric acid, Na positive, OH negative, and in here H positive and SO4 2 negative. This will move towards sodium and they will move towards each other, and we will have Na2SO4, sodium sulfate plus water. Another example of neutralization reaction in which one is base and this is acid. Next, as these are follow the same phenomena or follow the same mechanism which are followed by double displacement reaction, so these are also the subpart of double displacement reaction. That's why we are discussing it here. And now another example is KOH plus HCl. You will give me the product. Next reaction is ammonium hydroxide plus HCl. You will give me the product. Very simple, easy. And you will be wondering, what is this? You will be wondering about this compound. What is this? This is a ethanoic acid. This is an organic acid. This is an organic acid. Ethanoic acid, organic, acetic acid, सिरका. बेटा ਜਿਹੜਾ ਸਿਰਕਾ यूज करते ना ਆਪਾਂ ਘਰੇ, ਉਹ ਇਹ ਹੁੰਦਾ ਹੈ ਆਰਗੈਨਿਕ ਐਸਿਡ। ਇਹਨੂੰ ਕਿਉਂ ਕਹਿੰਦੇ ਨੇ? ਇਹਨੂੰ ਆਰਗੈਨਿਕ ਐਸਿਡ ਬੇਟਾ ਤਾਂ ਕਹਿੰਦੇ ਨੇ ਕਿਉਂਕਿ ਇਹ ਹਿਊਮਨ ਬੋਡੀ ਦੇ ਵਿੱਚ ਮਿਲਦਾ। ਜਿਹੜੇ ਐਸਿਡ, ਜਿਹੜੇ ਬੇਸਿਸ ਹਿਊਮਨ ਬੋਡੀ ਦੇ, ਜਿਹੜੇ ਐਸਿਡਸ ਬੇਸਿਕਲੀ ਜਾਂ ਫਿਰ ਜਿਹੜੇ ਕੰਪਾਊਂਡਸ ਹਿਊਮਨ ਬੋਡੀ ਦੇ ਵਿੱਚ ਮਿਲਦੇ ਨੇ, ਜਿਹਦੇ ਵਿੱਚ ਕਾਰਬੋਹਾਈਡਰੇਟਸ, ਫੈਟਸ, ਪ੍ਰੋਟੀਨਸ, these acids ਹੈ ਨਾ ਆ ਜਾਂਦੇ ਨੇ ਸਾਰੇ, those are called organic things because they contained in human body. If they are contained in human body, they are called organic. And this is a weak acid, but it is an acid. Why it is an acid? Because it will behave like CH3COO negative and H positive. This H positive will move to this OH negative part, and this CH3COO negative will move to Na. So the product will be CH3COONA plus H2O. Keep this in mind. We will discuss much of these compound in carbon and its compound chapter. Carbon and its compounds. 4th chapter of our chemistry book. This is the 4th chapter of our chemistry book in which we will deal with organic substances. We will deal with organic substances in those chapters. So, this was all about your double displacement reaction, and I know that you will got the thing, and you have got the thing, that these reactions are also based upon the cationic and anionic part, and now you have fairly known to the importance of your cationic and anionic part. So that's why even though I am since emphasizing that you should remember the cationic and anionic parts of the compounds with their valencies as well. So students, this is all for today about the double displacement reaction. We will continue to the next part, that is combination reaction, in the next chapter. Thank you.